I've been tutoring someone in statistics this year. It's been fun and very productive, very profitable. We've been able to get a lot out of it. We haven't been going over any class material, which is good. You know, we've been doing the statistics he's doing in class, but we touch on the material before he gets to it in class, and we do it much more in depth so he can see for himself where it comes from, instead of being given some concept out of nowhere. And so instead of just looking at some pictures or being told, you know, we've actually done some calculations to see how a binomial distribution works, what happens when we keep the number of trials the same, and how the distribution changes when we change the probability, and then how we can get the normal distribution from the binomial with a lot more repetitions. You know, binomial is basically like flipping a coin. You flip a coin, it can be heads or tails. There are only two choices every time. You flip a coin, that's like one trial. You flip it again, that's another trial. You flip it again, it's a third trial. But in every case, the probability is always 50%. 50% heads the first, or tails the first time, 50% the second, 50% the third. And then the trials are independent. So usually what happens in one trial doesn't affect the other. So it's a binomial distribution, bi meaning two, nomial meaning termed. So in this case, two probabilities, 50% heads, 50% tails. That's the idea. And we've got the probability is the same every time. There are two outcomes, and what happens one time doesn't depend on prior times, those three conditions. And we've looked at what a cumulative distribution would look like for each of those as well. Well, I won't go into detail, but we just looked at different binomial distributions and looked at their cumulative as well as distributions and looked at how it relates to the normal. So he's got a really good idea of this, but we've talked a lot about biology, which is something he loves. So we can really take this out of books and drive it home, bring it out into the real world and use it there, kind of develop it from the real world. So we're motivating what we're doing with putting it in terms of biology and animals and wildlife management and ecology, not just doing some kind of bookish examples that some people don't really care about. And we're looking at, as I say, stuff that he cares about, something he knows about, where he's going to use this more. That's part of the motivation thing, and developing it from the real world. And then we're getting into how to really think about statistics and use them. We're looking at some studies and stats people have used and how they're right or wrong. There's some things people do, like in nutrition, where they'll classify a pizza as a meat, and that's just ludicrous. You know, you cannot come to good conclusions about types of foods, vegetable, animal, grains, or whatever, when you're going to have a classification that ludicrous and that horrible. That just destroys the whole study. All that money is wasted. The thinking and reasoning is invalid at root, at core. So one thing we're going to get into next that unfortunately a lot of people don't is classification, how that works, what generalization is. A lot of people take statistical generalization as the be-all and get-all, the be-all and end-all. I mean, there's nothing more to it. Here's stats, and that's how we generalize and think, but that's totally invalid. That's just a small technique or small aspect of generalization in the much broader field of logic and thinking and epistemology. So when students are really going to do hypothesis tests, they should first learn some classification and some generalization. They should learn how generalization works the broader principles, then once they get that, statistical generalization will be much easier to understand and to criticize and to do right. Since a lot of people take statistical generalization as the be-all and end-all, that's part of it. Some poor epistemological principles in general, poor principles of thinking. That's what epistemology is about. What concepts are, how generalization works, what reasoning is, when we're correct in a conclusion, what logic is. When people have poor ideas about all that, then their statistical generalizations and their hypothesis tests are going to be horrible, not put together well, not designed well, just a waste of money and a waste of time and producing bad conclusions. So if students are taught generalization, they'll be much better off. That's how I think statistics should be thought, and that's the context in which it should be put. So most of my students, the ones that are willing to cooperate and that are curious and can really dig into this stuff, you know, some just unfortunately just want to focus on what they're doing in school. Very limited in their learning and their knowledge, their context. But the ones that want to dig into it, we can really get a better understanding of not just statistics, but thinking and reasoning. And of course, they can use that more in their everyday life. So just wanted to share that. That's something I've done that's made this guy just enjoy tutoring, be thrilled about it. He's, you know, paid for a package, and that's about out, and he's going to do more because he knows how valuable this is and how immeasurable the value he's getting out of it. So if you're out there and you're taking statistics and you're going to, let me know. I'd love to help. Love to help you see how this really is important in your life and how you can use it and help teach you and train you in broader principles of thinking and reasoning beyond just the statistical. You know, really delve into the statistical, but put it in context and see what more you can do to really get out of it, make the most of it, really learn how your mind works so you can use that in all areas of life going forward. Hope this helps. Thanks for watching. Hope you have a great day.